How we use things around us depends much on their being solid, liquid, or gas. What are the properties that distinguish each phase? In some restaurants, we sometimes find ice statues used as table centerpieces. Ice sculptors meticulously chisel the ice blocks to the shapes they want. A solid has rigid shape and volume. In the case of ice, it will maintain its rigid shape and volume as long as it stays frozen. But once it melts or turns liquid, it loses its shape. Its volume also changes because its density in its solid phase differs from its density in its liquid phase. Ice floats on water. This shows that ice is less dense than water. When it comes to this property, water is unique. It is the only substance which is less dense in its solid phase than in its liquid phase. All other substances have the opposite property. They are more dense as solids rather than as liquids for the same volume. This unique property of water is very important in supporting life and the environment. Protected from the cold by a layer of ice that floats rather than sinks in water, life thrives in lakes and oceans even during the winter. Solids are usually hard, but different solids vary in hardness. There are soft solids like lead and hard, heavy ones like iron. Some are brittle and crumble under mere pressure from our fingers. There are small, grainy solids like sand. Others are malleable like steel. Many of our farm implements and industrial equipment are made of steel. Liquids can easily be poured. They take the shape of whatever container they are in, but retain their volume before and after pouring. Liquids also flow just like rivers or streams. Being fluid or liquid, a soil solution is easily absorbed by plant roots and rises up the stem into the other parts of the plant. Our body cannot absorb and use the nutrients in our food unless these nutrients are in liquid solution. Some chemical reactions take place faster in the liquid state rather than in the solid state. The liquid and solid phases are called the condensed phases of matter. This is because matter in these phases occupies relatively smaller volumes than in the gaseous phase.